All right, so we've talked about function notation, about what's inputs, what's outputs, what's the x's, what's the y's. But now we're going to evaluate, which usually just means, a lot of times evaluate just means plug in. We're going to evaluate a lot of stuff. So the first function we're going to look at is, actually, there's only one function we're going to look at, and that's going to be f of x equals 2x minus 3. So f of negative 3, that is when x equals negative 3. So you just plug that in. Everywhere that there's an x gets replaced with a negative 3. It becomes 2 times negative 3 minus 3. So again, every x gets replaced, gets plural, replaced by negative 3. And then we need to simplify. So 2 times negative 3 is negative 6. Then subtract 3, you get negative 9. The input is negative 3. The output is negative 9. So that was this one up here. Let's do it for the rest. And again, this is another good time to pause the video and try to work through these on your own and make sure that we get the same thing. So pause the video, do these if you can, and then we'll go on together. F of 2, everywhere that there's an x gets replaced by positive 2. So 2x becomes 2 times 2. Minus 3, multiply this out, you're going to get 4 minus 3, which is 1. F of 2 is equal to positive 1. Next one, f of negative a. Jason, that looks weird. That makes me nervous. Well, don't. It's the same thing. Every x, every x just gets replaced by the input. Gets replaced, well, not by negative 3 anymore. Every x gets replaced by negative a. That's all this means. So we're replacing it with more things, and they're not numbers anymore, but it's the same idea. So 2x minus 3 becomes 2 not x anymore. It gets replaced by negative a minus 3. And then we still simplify. What's 2 times negative a? Negative 2a. And this is as simplified as it gets. This is what f of negative a is equal to. This is really going to appear later on in this chapter, later on in chapter 3. This is going to be a very valuable skill for you. So let's do another one. F of a plus 2. So we replace everything on the inside. X gets replaced by whatever's on the inside. But the outside is just tacked on. All right? So this really is just what is f of a and what is plus 2. So f of a, replace all the x's with a's. And then there's a plus 2. All right, so it really is just what is f of a? F of a is that. And there's a plus 2 at the end. Well, there's still a plus 2 at the end. That's what's going on right here. And then just like before, we simplify. So 2a doesn't simplify. We're collecting like terms though. Minus 3 plus 2 is minus 1. And last but not least, f of a plus h. This little guy is going to be making a very, very, very big appearance in calculus. If anyone's taking calculus, not everyone will, of course. Anyone taking calculus, this one right here, you're gonna get real sick of seeing that person. Or maybe you'll love them. So replace all the x's by a plus h. 2x? No, 2a plus h. And for the rest of you, you'll actually see this a lot in function composition when we get there. That's 3.5, I think. All right. replace everything, all the x's with a plus h's. And you get this. And again, we simplify. This time we simplify by distributing. Distribute that 2. 2 times a is 2h. 2 times a is 2a. 2 times h is 2h. And we have the minus 3, and these aren't like terms. So that is as simplified as it gets. I'll get my head out of the way. And there you go. That is how we evaluate functions. And there are a couple other ways that you can evaluate functions. But first, I want to take a brief side note and do another example problem from the homework because it looks a little bit complicated. This is example 6. It's very similar to one of your homework problems, but it's the even one, which I did not assign. This says, given g of x equals 5 minus x squared, evaluate g of x plus h minus g of x all over h. This is calculus almost. All right, so you can tell people, you can tell your family, you can tell your friends, hey, I did a little bit of calculus today with Jason. A little precursor, but it's a good problem. You have all the tools to do this. Calculus is not some mythical beast. It's just more complicated. All right, so here's what we're going to do. We just need to look at each one of these things. We need to figure out what this is, replace it. Figure out what this is, replace it. Well, we already know what this one is. G of x is this. So we're just taking each piece and replacing it. So g of x plus h, let's start with this one. This is a little weird. Everywhere that there's an x, we're going to replace with x plus h. Which is kind of weird because they both have x's, but replace x with x plus h. So g of x is this. Let's copy this down, but replace those x's. 5 minus x squared. Replace that x, though, with x plus h. And then do the same thing over here. So, right, this g of x is this. G of x plus h. We plugged in x plus h and wrote it out. Now we need to substitute g of x. Let's put it in parentheses. It's very important because it's getting subtracted. We're subtracting the whole thing. G of x is 5 minus x squared. So again, that's this piece. Now lastly, that's all divided by h. And we have to simplify. All right, so I'm going to go through this next bit a little quickly. It's useful for anyone going on in mathematics, but it's not as useful for anyone who's has Math 141 as their final course, final math course. So if we simplify this and this goes over your head a little bit, that's okay. If you want to spend some time on the simplification, it can be very good practice as well. So we're subtracting this. It's a perfect square. We have to FOIL that out. That's x plus h times x plus h. That's going to be x squared plus 2xh plus h squared. And now we have to distribute this negative sign. That's going to be minus 5 plus now x squared. H is in the bottom. Can't do anything about that. We're going to keep simplifying. So on a numerator, we're going to distribute that negative sign, 5 minus x squared, minus 2xh, right? This negative sign is going all three of these, minus h squared. And then we have a minus 5 plus x squared. And it's probably right about now when you're wondering, why the heck am I taking this class? I want to take this class with someone who's not Jason. But look, there's a light at the end of the tunnel. Look what good special stuff I have for you. We have a plus 5 right here. And we have a minus 5 right here. What's 5 minus 5? 0. You have a minus x squared plus x squared. What's minus x squared plus x squared? 0. Oh, not looking so bad now, huh? All right, so what's our numerator left with? Negative 2xh minus h squared all over h. Everything's got an h. We can factor out an h and cancel. Let's factor out a negative h even. No, let's not. Let's not. Let's just factor out an h. You could though. So if we factor out an h, what's left over? Well, a negative 2x is left over from the first one, and a minus h is left over from the second one. There's still that h on the bottom, and once it's factored, now we could cancel. So this whole nightmare that we started with is actually just negative 2x minus h. And again, this is a medium important problem for most of you, but a really important problem for anyone planning on taking calculus eventually. You'll be doing this a lot. But with practice, it gets a lot easier. All right. But it's a lot right now, probably for most of you. All right. I don't want to take up too much time with this, but you can ask me more questions if you have them. But we're going to move on and do 2 more examples in this video. Extra examples, if you feel ready to start the homework, you can pause the video and start the homework now. But extra examples showing different ways that different things can appear. So example 7, let's say we have this graph. Say we have graph paper too. All right, let's say we have a graph. And this graph passes through this point, and this point. Kind of. Oh no! It goes through the points, I promise. All right, that's closer. All right, it looks something like that. This graph. And I'm going to ask you a couple things about this graph. Part A is going to be, so let's say this is f of x. Part A is going to ask you to evaluate f of negative 1. Wait. Oh, I drew the wrong graph. It's going to ask you to evaluate f of positive 1. So remember, the input, that's the inside, or input or x. And it's asking when x is equal to 1, what is the y value? So you go to the x-axis and find where is x equals 1. X equals 1 is right here. Here are all the points where x equals 1. Here are all the points where x equals 1. Every point right there is x equal to 1. What's the y value of our function here? Well, the y value of our function here is right there. That's a y value of positive 1. Okay? So that's kind of our answer. And our input is 1. Our output, in this case, is also 1. Similarly, you could write f of 4 equals positive 2. Similar to go back to the, similar with the last video as well. What about solve for f of x equals 2? So this is backwards. Notice the relationship between these two questions. In the first question, I gave you the input and we had to find the output. But now I'm giving you the output and we have to find the input. So again, it's the same logic. This is our output, or the y. So we're going to look at all of the values that have a y value of 2. All the values that have a y value of 2, where does it cross the graph? Y value of 2 is right there. Okay, a y value of 2 at this point, what is the x coordinate there? The x coordinate right here is 4. That's the solution right there. So it just depends. If you're looking for an x value, you'll draw a vertical line. That's all the places with an x value of something. If you're looking at a y value, you can think of a horizontal line, and that is all the points that have a y value of a certain value. All right, let's do one last one. Similar take on the same problem. Example 8 is going to be a table. Again, a table giving you all the inputs and all the outputs. Inputs are x, outputs are y's. And again, let's say 0, 2, 4, 6. And again, of 0, 4, 16, 36. Part 1 is going to be evaluate f of 2. So again, 2 is that input. The inputs are all up here. And again, that's our input inside the parentheses. Our answer is, well, 2 is our input. What's our output? 4. And that's our answer here. And we could do something similar for part B. Solve f of x equals 16. And again, this is telling us our output and wanting us to find the input. All right, so we'll look at our outputs. Remember, our outputs are all this stuff down here. Look at our output, find 16. What input gets us to 16? 4. That's our answer. When x is equal to 4 is when we get that output. So this video turned out to be a little longer than I wanted it to be. I usually like to keep them within 10 minutes long, but there's a lot of different example problems because there's a lot of different ways that these problems can appear. So I wanted to give you more things rather than fewer to go on for your homework. But as you're working through the homework, if you do have questions, reach out to me, and good luck.